All right. So this is the F word, and this is what people talk about. And of course, the F word we're talking about here is centrifugal. Yes? Okay. I don't know. You probably have heard of centrifugal force. As I spin this thing, there's tension in this cord. Yes? To me, it seems, at least in my frame of reference, that it's being flung to the outside by some mysterious force. Right? Now, you guys are far more discerning than that. You understand that in order for it to go in a circle, it's got to accelerate toward the middle. Yes? And in order for it to accelerate toward the middle, if it is accelerating toward the middle, it'll feel thrown to the outside. It's just like if I accelerate linearly that way, I feel thrown backwards. If I accelerate toward the middle, I feel thrown to the outside, right? Now, in general, it's just the tendency of an object to go straight. And if it comes off of the curve, if it quits going in a circle, it's going to go off tangentially. We talked about that last time, but let me give you an example, right? I use the F word. You know, I know you guys kind of put me up on a pedestal, and you probably don't think I've ever used the F word, but I did use the F word. I was driving. I just bought these Glacier glasses. They cost a whopping $30. I mean, why does a pair of sunglasses cost $30, you know? Isn't that an amazing amount to spend on sunglasses? Yeah, holy cow, right? And I'm in my car, and there I am driving along, right? And the sunglasses were on. I'm about to go around a corner. That's like a joke. I know they cost like hundreds of dollars, right? You know? Okay, but I'm about to go around a corner, and they are on the right side of the dashboard. And I've got my Volkswagen Rabbit. It's got like this flat spot, right? Then it goes up, and there's like a little instrument thing, right? And then it's a sunny day. It's hot. I've got the window open. There's no air conditioning. Are you picturing this? Sunglasses are safely over there. I start to go around the corner, right? In another moment, I'm here, and my sunglasses have slid across the dashboard. There they go, right? They start to move toward the outside of the turn. Magically, they were at rest, suddenly they start to move toward the outside of the curve, right? And then they kind of skip up over that little hump. Out the window they go. At that point, I used the F word, right? I said centrifugal force through the glasses out the window, yes? Yeah. There we go. I used a different F word too. But I won't repeat that one here, right? So here I am, right? Now I'm like here. I said the other F word was forget about them, you know. Forget about these things, right? I'm looking out the window, right? These glasses are now, you know, like right there, right? Okay. And to me it looks, as I go around this corner, to me it looks like they're going off radially. But what are they really doing? They're really leaving the car, and they are going tangent to the car's motion, aren't they? Isn't this path that they're following a tangent? But in that frame of reference, it looks to me like it's radial, doesn't it? Radial just means along the radius, that they're going outward like that. But you know, rest assured, there's not on the outside of all car corners that you can go around little magnets that suck things to the outside of the curve. It's just the tendency of objects to go straight that makes it look like it's doing that. Yeah? Curve a bullet. Yeah. Is that like really impossible? Well, if you could exert a force on a bullet, you could curve it, right? So like baseballs can curve because they put spin on them and they interact with the air, right? I mean, they're going like 90 miles an hour, so they're, yeah. So that's real. Bullets could curve. You know, the U.S. uses M16s, which are these like high velocity rounds, and when they hit small things like a little bit of jungle debris or something like that, or a twig or something, they will spin out of control. And yeah, they'll go around corners, you know. They won't go where you think they're going to go, right? Which is a drawback for high velocity rounds, right? Okay, so with air friction, yeah, they can go around corners, but not otherwise in general. Now, this concept that objects are fly off tangentially, I deeply, deeply did not understand this as a child, right? So I went biking. They put fresh asphalt on Emmert Street. It was the name of the street. I don't know why it was called Emmert Street, but it was like a street that was paved near my house, not so busy. It was where I rode my bike. And when they put fresh asphalt on it, I rode my bike on the fresh asphalt. I did not have a rear fender, and so sticky tar was on my back. Did my mom like this? No, not so much. Moms are not so big on tar being on the back of your clothing because it has to be removed with gasoline or kerosene or something like that, right? You can't wash it off with soap and water, right? And so I knew what was going on, right? Here, this is the picture. Here's my bike tire. Here is, you know, I had one of those. Remember those? Did you ever have a bike with a banana seat? Yeah, like just like a motorcycle. Yeah, yeah, just like a motorcycle. And then they have like this little bar that goes way up high, like that. Like I don't know, it's like the '70s. Like, whoa, look at my thing, big handlebar. Yeah, I'm driving a motorcycle, right? Put cards on that thing, right? I knew. Here's my here's the kid butt. Here's the head, right? You know, here's the legs pedaling or something like that. My butt, right? I knew that the stuff that was hitting my back was flying off like this. That's not correct, right? That is not correct. They don't fly off really radially. They just seem to in that frame of reference, right? So what I did was I took a little thing and I made a cardboard fender. I was always making stuff. I probably made it with masking tape, right? I made a cardboard fender so that there was no way that this wheel could see my back. It was blocked by, you know, like that, right? Okay. Rode my bike on Emert Street. What happened? Well, it's not flying off like that. Where's it flying off? It's flying off here, right? Here. I mean, it's not going absolutely straight. It's curving because of, you know, the gravity, right? But pretty much it's pretty straight, right? I was amazed. I got tar on my back surprisingly low. Yeah, because it's flying off at a tangent. Yeah? Does that make sense? Deeply didn't understand that. That was like magic to me. I was like, well, what the heck? Right? Yeah. Not always a physicist, right? Just later on in life, you know. Okay. How about, do you guys ever play corners? Like you're the little kid in the car and then everybody yells corners and they jam you against the outside of the curve. Do you ever do that? Yeah. In our family it was called centrifugal force. I guess we were a physics-oriented family, right? My mom's father, my grandfather, was like a PhD physicist, worked for Shell Oil, right? So we would yell corner or we'd yell centrifugal force and then it never worked the other way. If my brother was on the outside of the curve, he was always bigger than me and I could never crush him. But I always got crushed. It was like I got to know that side of the car. I wonder how many kids get like ejected from the car unwittingly by older. Da-da-da, yay. Water from the salad. The F word. All right. Okay, let's go. Let's take a look at bank corners. Yes? Okay. On a flat road, and we're not going to really do a lot of friction stuff on bank corners, but on a flat road, if you've got a curve that's flat, right? Okay. The car coming toward you has its tires. If the tires are cleverly arranged, there's like a McPherson strut suspension or something even more clever, right? It's proprietary, right? As this car comes toward you, the friction with the roads, the mu times m times g, can equal, well, the mv squared over r, right? So this is the car. This is my car coming toward you, right? It's like, yeah. That's what my car of my dreams looks like coming toward you. Yes, are you picturing this? Right? There I am in a Formula One or something like that, right? You got the, I can draw this. Right? You even have like little wings off to the side like that, right? Okay. But anyway, on a flat corner, the only thing providing lateral force for you to go around the corner is friction. What happens if there's ice? You don't go around the corner, you go straight, you go tangentially, right? You go off the curve tangentially, right? Off you go, right? Okay. But generally there's, there we have it, right? And then, of course, this is assuming that it's only the weight holding you down. This is not a very good assumption for a Formula One car. Do we know why? It's not just the weight holding it down. What else is holding it down? The spoiler is holding it down. And those spoilers are real, unlike the ones that people screw onto their trunks of their car. You go, I have a spoiler, I'm cool. No. Okay. Those probably aren't as important as these guys. These guys, Formula One racers, are more like airplanes than like cars. Okay? If you could properly oil the engine, they could drive on the ceiling. They generate at speed more downforce than they weigh. Think about that. They generate more downforce than they weigh. So if you could design a road, they could drive upside down. Not quite as well, right? They would own, by the way, in reality, they would turn upside down, all the oil would go into the cylinder heads, and they would die very quickly if they turned upside down, right? Engines, you can't, if you take your lawnmower and tip it on its side and run it, it'll quit oiling and burn up in a second. So, only airplane engines can they can oil in any direction. That's an important situation, right? An important thing to think about, right? So, anyway, that's assuming this. Now, do you guys know about the Indianapolis, the guy that won the Indianapolis by making a car that sucked itself down to the road? Did you hear that story? No. Okay, this guy makes a car, It doesn't have spoilers on it because maybe they hadn't figured out spoilers or something like that, right? It's got a fan. It's got two motors maybe, right? But it's got